Hi there! Welcome to Raelene Maths. In this video, I would like to set the record straight. I am often told that I teach maths differently, and I guess it's true. Let me show you how in terms of solving absolute value equations and inequalities. I often see people solving an absolute value equation like this. Knowing that we need to undo what's being done to x, the first thing we have to do is undo the absolute value. And so people write x minus 5 is equal to 7, and then a vertical line, and then x minus 5 equals negative 7. Solving these two linear equations then is pretty straightforward. We get x equals 12 on this side, and on the other side, negative 7 plus 5 gives negative 2. These numbers are important, but what's unclear to me is this vertical line. Does this vertical line mean and, or does it mean or? If you know what the answer is, then we can interpret the right word, in this case or. So the solution to this equation is actually x equals negative 2 or 12. But we're not really clear from this vertical line. What's worse is that this approach often gets extended to solve an inequality, like number 2 or 3. If we apply the same setup to number 2 then, we get x minus 5 is greater than 7, then a vertical line, and then x minus 5 is greater than negative 7. Solving this linear inequality by adding 5 to both sides gives x greater than 12, and on the other side, x greater than negative 2. So if we assume from number 1 that the vertical line means or, this is saying that x is greater than 12 or x is greater than negative 2. And the statement here simplifies to simply the set of x values greater than negative 2. Well, these values don't work here. For example, if we were to substitute 0, which is a number greater than negative 2, into the inequality, 0 minus 5 is negative 5, and the absolute value of negative 5 is 5. 5, however, is not greater than 7. So there's something flawed in this approach. So instead, we memorize what we need to do to get the correct answer. And in this particular case, with a greater than symbol, we are told to memorize to flip this inequality symbol so that we get x is less than negative 2. And so our statement ends up being x less than negative 2 or x greater than 12. This is not satisfactory to me. There's a couple of inherent misconceptions, and we still don't know how to apply it to the third case. So yes, I teach maths differently. Let me show you how I would approach this from a more meaningful, one-dimensional geometric approach. So I'd like to go back to the basics. The first thing is that distance in one dimension can be represented by the absolute value. For example, the distance between x and 5 is expressed as the absolute value of x minus 5. And furthermore, the distance between 5 and x is represented as the absolute value of 5 minus x. And of course, the distance between x and 5 and between 5 and x is the same. So those two absolute value expressions are equal to each other. Another truth is that we can express absolute value as a piecewise function. And so what that means is, if you take the absolute value of some stuff, and if that stuff is positive or 0, then the absolute value of that stuff doesn't change the value. But if the stuff is negative, and we take the absolute value, then the job or the role of the absolute value is to change the sign of the stuff. We write that in piecewise notation with this curly bracket with two different lines depending on whether the input stuff is negative or if the input stuff is non-negative. So what does that mean for us? In the first example, when we see something like the absolute value of x minus 5 equal to 7, we can express this verbally as the distance between x and 5 is 7 spaces. And I like to reword that slightly differently so that we can look at it from the point of view of x. In other words, we know that x is 7 spaces away from 5. And we know that absolute value is one-dimensional distance. And so here we have that the 7 is a distance and the 5 is some kind of center. And so if we happen to be on a number line, an x-axis, and the 5 is some center, we want x to be 7 spaces away from that. And we only have two options to go in one dimension. We could go to the right of 5 or to the left of 5 by 7 spaces. Now I know I said that distance is one dimension, but I'm actually going to draw a circle because I really like the visual of the circle and I like to be able to extend into 2 dimensions for distance. In this case then, my distance is the same as the radius of the circle. So the distance or the radius is equal to 7. And so if we go 7 spaces to the right, that takes us to an x value, which is 5 plus 7. In other words, 12. However, if we go 7 spaces to the left, we get to a second x-coordinate, which could satisfy this statement, which is 5 minus 7, which is equal to negative 2. And from here we can see that our solution is going to be x equals negative 2 or 12. Now we did get that with the first algebraic solving, but it wasn't really clear and it didn't extend to the next case for the absolute value. So let's use this verbal interpretation in the second question. Here this says that the distance between x and 5 is more than 7 spaces. And so we can read that from the point of view of x, which is to say x is more than 7 spaces away from 5. So on our number line, we could still look at a center of 5. We could look at a circle of radius 7. I'm going to move my circle over a little bit. My circle of radius 7 here still tells me that if I were an x-coordinate on the boundary of the circle, on the circumference, x would either be negative 2 or 12. I'm not going to put a solid point there. But in this statement here, x should be or is more than 7 spaces from 5. And so this is suggesting that x can either be on the circle, inside the circle, or outside the circle on the x-axis. And in order to be more than 7 spaces away from 5, the center, x needs to be not equal to 12 or equal to negative 2, but on the outsides like this. And so when we go back to our set notation and understanding how to write this one-dimensional set, we get the solution that x is any point that's over here in blue or over here, so x is less than negative 2 or 12 is less than x. Of course, we can write that second set as x is greater than 12. Now, if you memorize the solution from earlier, you will get the right thing, but at least here we have a visual geometric interpretation which is consistent with what we did in the equation case. In the equation case, x needs to be exactly 7 spaces away from the center, and in this inequality, x is to be more than or beyond 7 spaces away, so outside of the circle. So you can pause the video and try this next one on your own by thinking verbally and interpreting this inequality statement in one dimension. Okay, so what it really says is that the distance between x and 5 is less than or exactly equal to 7 spaces. And from the point of view of x, this means that x is, I'll put therefore, x is less than or exactly 7 spaces from the center of 5. So on our number line, which is the x-axis, we are going to have a circle, and the radius of that circle is going to be 7. We have a center at 5, and we could go exactly 7 spaces to the left or to the right of the center along the x-axis. Now our question is asking us to find the x values that are less than 7 spaces from 5 or exactly 7 spaces from 5. So to be exactly 7 spaces from 5, x could either be at negative 2 or 12 again, because we do have an equation here. But we also want x to be any point on the number line which is less than 7 spaces away, meaning inside the circle. And so here we end up getting a solution that says x is any point in red, which happens to lie in between the negative 2 and the 12. So negative 2 is less than or equal to x, which is less than or equal to 12. Coincidentally, this is a compound inequality, and if we were to separate that compound inequality, it would say negative 2 is less than or equal to x, and x is less than or equal to 12. So in the case that we were taking the two absolute value statements and breaking it apart with a vertical line, in this case, the vertical line is representing and not or, like we saw in the previous cases. I've spent a lot of time now talking about this blue information, how absolute value represents distance in one dimension, but I haven't touched much on this red information that we can use piecewise notation to express absolute value. So I'm going to refer back to this in finding out what exactly went wrong in the traditional common approach for solving absolute value equations. We notice that it's not the outside of the absolute value, the 7, which gets changed by plus or minus, but rather the inside stuff. Here we see that this x minus 5 is the stuff that is either multiplied by positive 1 or negative 1, depending on the sign of the stuff inside. So if we were to modify this and say that we're taking x minus 5 and either multiplying by plus or minus 1, instead of the 7, which is getting multiplied by plus or minus 1, then we would have a better shot at success. This would still give us that negative times x minus 5 equals 7, or positive times x minus 5 equals 7, which gives us x minus 5 equals negative 7, or x minus 5 equals 7. And from here we get the same answers of negative 2 or 12. The impact really comes along if we have an inequality symbol here. So if we took the second question, which was x minus 5 in absolute value greater than 7, we would see now that removing the absolute value symbols is impacted by putting plus or minus around the stuff and not around the 7, as is typically done. We still have a problem here, and I didn't address it here, as to how we get and or. But without that, at least we're getting the right sign change for the inequality that we were just memorizing in the previous explanation. So here, if we want to multiply through by negative, we would have to flip the inequality symbol. Of course, that's because we're really thinking of adding terms to both sides of the inequality, keeping the inequality fixed, and getting a negative 7 on the left and positive x minus 5 on the right. Either way, we're getting that negative 2 is greater than x. In other words, x is less than negative 2, and from the other side we're going to get that x is greater than 12. Again, it still begs the question, do we have and versus or? And I don't think that this approach really handles it very well. I do like the one-dimensional graphical or geometric approach, and I'm going to show you another approach using two-dimensional graphing in the next video. If you like the video, click like and subscribe to my channel. Stay tuned for more on solving absolute value equations and inequalities. Thanks for checking out Raelene Maths.